Okay, so we're going to do the ambiguous case today. Some people call this the donkey triangle. It is the side-side angle. I won't ever write it as angle side-side because then I lose my job and I need that. So, all right, here we go. Now, what happens is you're going to be given an angle, one angle, and two sides of a triangle. And if the angle's acute, if that angle they give you is small, then there are 4 possible outcomes that could happen. And that makes it tough, okay? So, possible outcome number 1. You could get 0 triangles. So let me show you. What they do is they give you, so they're going to give you angle A, this angle right here. Then they give you side B, and they give you side A. But they don't give you an A that's long enough. So there's no solution. Okay, I'm going to show you what happens, what you do about that. There could be one triangle, exactly one triangle that works, and that would be a right triangle. So that's pretty interesting. If A is acute and they give you a really long side here, only one triangle is going to work. Okay? Now here's the part that people don't like. It's the 4th one. This one right here has 2 solutions. So let me show you what that looks like. They give you angle A. They tell you how big angle A is. They tell you the length of side B. And then they give you this side A. Now, if I walked up, I would go, okay, I'm going to put side A right here, and it's going to form this triangle. Someone else walks up and goes, no, I'm going to swing that over here. It's the same length A, but it's going to make this triangle. Well, who's right? They both are. It makes 2 triangles. This length of A that they give you, so they give you this angle, this side. This A just so happens to make 2 triangles by either putting it here or there. You get 2. You see that? I know. Now, if A is obtuse, an obtuse angle, that's a large angle over 90, then you're only going to either get 0 solutions or 1 solution. So that's nice. When it's obtuse, only one answer occurs, and we like that. Okay, now what I do, instead of trying to memorize all this stuff, what size is A? Can I compare that to B? And are there going to be 2 angles? I just assume, see, ASS, side-side angle. I assume 2 triangles to see if they both work. Okay, here we go. Let's do it. I've got, oh no, what did I do? Okay, it's this one, right here. They gave me this angle, they gave me this side, but this side A is too short to work. Won't work. Examples for you. And I'm going to be a little bit of a spoiler alert here. One of them's not going to work, one of them's going to have 1 solution, and the other one's going to have 2. We'll see which one's which. Okay, let's look. Number 1. I'm given that A is 85 degrees. So let me go ahead and open this up to 85 degrees. So let's say this is A. A is 85. It might have been a little bit larger than that. It's almost to 90. And then we'll call this angle B over here, and this will be C up here. Side B is 25. It's pretty long. 25. And then side A is only 15. See, that might not make a triangle. It's not going to. But let's say that we couldn't tell that. Let's just finish it. Let's put 15 over here, set up our triangle as normal, and let's start solving, okay? Just start solving. If you can't see it, that it's not going to work, just go ahead and do the law of sines anyways. So let's look at this. We have a ratio, and then we have half of a ratio. So our first job, our first step in all of this is to find out what angle B is. Okay? So how are we going to set this up? Sine of B over 25 equals the sine of A, 85, over 15. All right, make sure that you're still in degree mode and doing all of these. So you go to your calculator, you multiply by 25. So 25 times the sine of 85 divided by 15. Now, we end up getting that the sine of B is 1.66 ... Now, do you see a problem with that? You should. Okay? If you don't, you're like, I don't see any problem with that, then go ahead, go to your calculator, and find the sine inverse of 1.66. Your calculator sees a problem with it, that's for sure. Your calculator says, domain, quit. Oh no, my calculator just malfunctioned. No, it didn't. You can't take the sine inverse of 1.66, okay? Think about it. What this is asking you is what angle equals 1.66 for the sine. Here's the sine wave, right? You all agree that's the sine wave? Pretty close. It's pretty good. And then here is 1.66 up here. Do these two ever cross? No, they don't. There's no such angle that's going to give you 1.66. All of your sine of 30, sine of 60, sine of 40, sine of 180, sine of whatever are always between -1 and 1. Always. Anything above or below that is not going to work. And so this triangle, there's no such triangle that works given this information. This side is just simply too short. It's like that first one on that page over here. You're going to like these. You know why? This is what you do. No solution, and then you move on. Okay? There's nothing to find. There's no angles, no measures, and you're done. Should I put 10 of those on the next quiz? No. Okay. It's worth a try. All right, number 2. All right, number 2 is going to be an interesting one, so let's do it. Here we go. So now we have that A is 20 degrees, so A is pretty small. Here's A, and you don't have to draw them to scale. I usually don't, but I'm trying to. 20.5. B is pretty long. We'll say this is angle B. B is pretty long. It's 31. And then side A is 12. Now here's the thing about side A. Side A could either come down over here or it could come down over here. Do you see that? And what happens is you're going to get 2 different triangles from it, okay? So what I want you to do is just set up your one triangle for right now. Okay, let's just ignore this right here. And we'll just set up one triangle, but I'm going to show you how to find both of them that actually work here. So this is side A, this is angle C up here, and this is side C. All right, so what do we have? We have, A is 12. Let me write 12 right there. There we go. All right, so I have a ratio, and then I have half of a ratio. So let's set it up. We have the sine of B over 31 equals the sine of 20.5 over 12. Okay, so multiply by 31, and we get 31 times the sine of 20.5 divided by 12. And I get that the sine of B is about 0.905, and then take the sine inverse. You know where that's at, right, on your calculator? Yeah? It's right above sine. It looks like this, sine to the -1. So that's the sine inverse button. So you're going to take the sine inverse of 0.905. So I usually just go sine inverse of my answer. Do you ever use that answer button? I love that answer button. And I get 64.8 degrees. Okay, now here we go. B is 64.8 degrees. And I'm going to call that B1 because there's actually going to be a B2 that could possibly work. See, if my triangle ended up being the one that I drew right here, that's great. But what about the one that I erased? Isn't this angle B? Well, what's that angle? Okay, let me show you what that angle is. Now, you know that when you take the sine inverse of a positive number, you should get 2 answers from 0 to 360. You should get one in quadrant 1, and where else? Quadrant 2. Quadrant 2, okay? So what you're really doing is you got the 64, but there's also one that has a reference angle of 64.8. Oops, 8. So how do we find out the other angle that could possibly be angle B? It's going to be 180 minus B1. That's how you always see if there's a second angle there. So 180 minus that 64.8 gives you 115.2. So in my triangle that I drew up here, I wish I didn't draw so much stuff on it, but basically you have this side coming down and making this the 64.8, or you have it coming down over here and this makes 115.2. Okay? Now, at this point, we need to then find two angle C's. Do you see how angle C up here could either be this or it could be this angle? So there's two angle C's that are possible. So now I need to find out what angle C1 is. C1 is going to be 180 minus angle A, which does not change, they give that to you, minus B1, which is 64.8. So let's find that. 180 minus 20.5 minus 64.8. Oops. What'd you get? Did you do it? 94.7? No? No one's doing it? Let me just make sure. Yeah. Sometimes I make mistakes on my calculator. So annoying, huh? All right, 94.7 is what I got. So here's B1. Here's C1. And now let's do C2. C2 is going to be 180 minus 115.2 minus 20.5. Sometimes C2 doesn't work, and then that means that there's only one triangle possible. 115.2 minus 20.5 gives you 44.3 degrees. Okay? All right, we still have to find one more thing. Actually, two more things. Now, when you have this type of triangle, do you see how C is going to change also, side C? I could have this triangle here, which gives me this little C, or I can have this triangle here, which gives me this big C. So now I need to find those. And they're not bad to find. You just use law of sines. C1 over the sine of 94.7, because that's angle C1, equals, use your ratio, 12 over the sine of 20.5. That's going to give you the smaller, or the bigger C, actually, because 94, across from 94. So let's do it. Sine of, or 12 times the sine of 94.7 divided by the sine of 20.5 gives you 34.2. Okay? And then C2 would be to do the whole thing over, but instead of using 94.7 here, we're going to use C2's angle of 44.3. You can always hit second enter and go back and just redo that. 94.7, put in a 44.3 instead. And then side C2 will then be 23.9. All right, there's a lot to find when there's two triangles. It's kind of a bummer, okay, because it's making two angle C's, two angle B's, and two side C's. What a pain. This is the stuff that RAM skips. So if you want to know kind of the difference between our classes, they've already done law of sines and law of cosines, but they skip this hard part, but we do it. So, okay, let's do the last one. Here we go. We've got a 42-degree angle for A. That's about that degrees. 42 degrees. Here's B. So this is 12. And then I have a pretty long side A of 22. See how this wouldn't give me two triangles? I can't swing it this way because it's gonna go past. Like this side A, which is 22, if I were to try and swing it this way, it would be like way over here. It's not gonna make a triangle. So there's only one triangle for this. If you don't see that there's only one triangle, that's okay. We're gonna pretend like we think there's two and do it, okay? So here we go. This is what we're gonna do. We're gonna solve for angle B first. So sine of B over 12 equals sine of 42 over 22. This is a side-side angle problem. The side-side angles are going to be the only one that you're going to hate. The rest of them are pretty easy. They're pretty straightforward. We're going to learn law of cosines tomorrow, and you'll see what that looks like. But this is the one that has the possible two solutions. Okay, so 12 times the sine of 42 divided by 22 gives me 0.3649. Then I take the sine inverse of that answer, and I get that B1 is 21.4. Now, here's where I just kind of assume, like, if you can see there's only one answer, then just stop. I would see that there's only one answer in this triangle. I'd probably stop. But if you want to make sure, go and try and do B2. B2 is going to be 180 minus that answer, 158.6. Okay? So this is the question mark. Are there two triangles? And you can see right away that there won't be two triangles. I'll show you. If there's two triangles, then this would be to find the angle C that goes with this. It would be 180 minus 42 minus 158.6. Well, guess what? That's negative. So this is not a triangle. That's going to give you a negative angle C. Bad. Okay? So there's only one answer, and you'll like that. Good. We only have to find one thing. I don't have to worry about this weird one. It's just one triangle happening. So what do I need now? I have angle C, or angle B. Let's find angle C now. Angle C is 180 minus angle A minus angle B. Okay? So 180 minus 42 minus 21.4. 116.6. And then the last thing I need to find is side C. So this is a pretty big angle here, because this is such a long, I mean, and this isn't even really drawn to scale, but this is such a long length that this is going to give you a nice big obtuse angle. So 116. So here we go. I need to find C. Side C over the sine of 116.6 equals, and I would stick with my original ratio, bless you, 22 over the sine of 42. So 22 times the sine of 116.6 divided by the sine of 42, 29.4. So side C is 29.4. So we found all of it, all three parts that we needed. And I'm not going to tell you which ones have three or two solutions. You'll have to find those on your own. Even on the quiz, I'll just say solve the triangles, and if there's more than one, solve both of those triangles for the information. So, but the only time it's going to occur is side-side angle. That's the only time it can occur, okay?